Hi, this is John Sonmez from Pluralsight, and welcome to the second part of Java Fundamentals. In this course, we are going to be building on some of the concepts that we had covered in part one of the Java Fundamentals course. In that course, we really went into the language features of Java, the basic understanding of Java and what is Java. In this course, we're going to go a little bit more in depth, still kind of in the basics of Java, but we're going to go into some more of the features of the Java language and get into a little bit of the libraries for some of the common things that you're going to need to know how to do to be a successful Java programmer. So let's take a look at some of the topics that we are going to cover in this course. Well, the first thing that we're going to cover in this module here is exception handling, and we're going to talk a little bit about how to catch and handle exceptions in Java and some of the unique things around exception handling that exist in the Java programming language as opposed to other languages that have exceptions. And then we are going to introduce the concept of collections, which are basically a way to contain a set of objects, basically in Java. So different collections exist for different purposes, different algorithms. You can have collections that operate as a list, some that operate as a map or dictionary, and some that operate as a set, and so on and so forth. We're going to talk about some of the common collections in Java and build on some of the information that we had learned about generics. Then we are going to cover enumerations. Enumerations are also a very special type of class in Java, and they are a lot different than enumerations in other programming languages. So it really is important to understand some of these differences in Java, and we're going to cover those, and I'm going to show you how to use enumerations effectively in Java. Then we're going to cover a pretty important topic in any programming language is I/O. I'm going to show you how to actually do I/O operations in Java and explain a little bit about the decorator pattern that makes those I/O operations possible. Then we'll get into annotations, and this is a fairly complex subject, not something that you might use every day as far as creating your own annotations, but I'm going to show you some of the existing annotations in Java, and then I'll show you, if you wanted to, how to create annotations and parse them in Java. And finally, we're going to cover a topic that I think every Java programmer kind of needs to know in today's development environment, and that is threading. So we are going to try to break this down, make this fairly simple for an introduction to threading in Java, and we are going to learn how to write Java programs that can be multi-threaded. This first module in the Java Fundamentals Part 2 course is on exception handling. And we're going to talk a little bit about what exceptions are and how to use exceptions effectively in Java. So let's go over what we're going to cover specifically in this module. The first thing that we're going to do is talk about exceptions, kind of get a clear understanding of what an exception is, why you use an exception, and what purpose it serves in the Java programming language. Then we'll go into some demonstrations of using exceptions. I'm going to show you how to use a try and catch block to basically wrap some code in a exception handler and to be able to catch an exception that's thrown by that code. Then we will introduce a new concept called the finally block, and we'll see how we can use this block in order to execute some code no matter what happens, whether we have an exception being thrown or the code executes without throwing an exception. Then we'll talk about kind of a complicated thing as far as exceptions in Java and kind of a controversial feature, which is this idea of checked and unchecked exceptions. We'll answer the question of what is the difference between the two and how should you handle each of the types of exceptions, checked and unchecked. And then finally, we're going to get into some best practices. Exception handling is one of those things that is often debated pretty hotly in Java, and I'm going to give you some of the best practices that are out there, some of the ones that I think are best, and we're even going to debate some of these and talk about some of the pros and cons, some of the different viewpoints that exist for these best practices. An exception, and why do we care about exceptions in Java? Well, the basic thing that an exception is it's a way to handle errors. It's an error handling mechanism that's built into the language. Exception handling started being put into languages because of some of the problems with the error handling techniques that were used before there was such a thing as exception handling. It could get pretty complicated. I'm going to show you some examples of that. We're going to kind of talk about this in a little bit here. But basically, exceptions are just a way to indicate that there's an error and to handle that error. Now, in Java, an exception is basically a special object that indicates that there has been some kind of error or exceptional situation that needs to be handled. The code needs to be halted if it's not handled. And in Java, all exceptions basically inherit from a common type called throwable. So they're basically any class or object belonging to this tree hierarchy that starts with throwable. And exceptions in Java have the ability to end your application. If you throw an exception in Java, or there's some code that throws an exception in, that exception isn't handled or dealt with in your Java program, it's going to actually crash that program. And that is by design, and that's kind of important because the idea here is that if something happens and it's an error condition that you didn't expect or your code isn't able to handle, we don't want to just keep on going through, because even though crashing an application is a bad thing, the worst thing is to corrupt data. Really, when you talk about the severity of errors that happen and that annoy users, really the worst thing you could possibly do is corrupt data. And really the worst extreme of that is to corrupt data without anyone knowing it, because months could go by and you're building on corrupted data. So really the purpose of exceptions is to indicate there's an error and indicate that if it's not dealt with, this application is going to crash. And usually that's a better behavior than corrupting data. So let's kind of look at how exceptions work in Java and try to understand why they exist. So as I said before, exceptions are really, they're better than error codes. If you have a C background, even a C++ background to some degree, but more so kind of low-level C programming, you're probably familiar with error codes. And a lot of people have come up with a lot of clever ways to implement error codes. Some people have stuffed them into arrays of bits, or basically bit flags, things that allow you to basically figure out what went wrong in the program and have a variety of different error codes. And maybe you've even programmed this way before. Maybe you've done this in Java or in C# or in C++, where you've started returning back an integer or some kind of string or something that indicates what kind of error had happened. Well, exceptions are kind of designed to defeat that because of kind of a problem that can occur in that case. I have a diagram here where I'm showing some method calls. And you can see here we have method A is calling into method B, and then method B is calling into method C, and then method C hit an error. It hit a condition that it needs to deal with that it cannot deal with. So method C can't handle this problem. It's an error. Maybe it opened up a file and that file didn't exist. So what's going to happen here if you didn't have exceptions? Well, without exceptions, the standard way that you would have to deal with this problem is method C would need to be able to check for that condition and then return some kind of error message. Maybe even it just returned true or false, and it would have to return false back down to method B. And method B would then have to return that message back up to method A, and then method A would have to deal with it or return it from wherever it called. So you end up with this problem, especially if you're doing refactoring. If you've ever written some error handling code like this, and then you've refactored that code, maybe you've taken out another method, you've done the extract refactor to take some code and pull it out and make a method out of it, then you've realized that you now have to return a value from that method, an error code or a true or false, and you have to bubble that all the way up the stack here. So an exception basically works the same way as this, except that it is automatically going to look up the stack of method calls for a special clause, which is a catch clause, that is able to handle that exception. So in Java, we use this concept. We basically say, okay, in that scenario, we would have maybe method A calls method B calls method C tries to read some file on disk, it doesn't exist, so method C throws an exception. Now that exception is going to say, hey, is there somewhere up the stack that can handle me? It's going to look in method C first, where it originated. Can you handle me? Have you said that you can handle me? No. It's going to look in method B. Can you handle me? No. It's going to look in method A. Can you handle me? Yes. Okay. And then it'll be handled. So this is going to prevent you from having to return back an error message or error conditions or error codes, and instead method C is going to be able to return back maybe what it should. Maybe it's supposed to return some text from a file instead of trying to overload what these methods return in order to bring back error codes. So that's kind of the big picture of why we have exceptions in Java and what they are doing for you. And we're going to get into the code now and start to look at how we actually implement this. And the basic way that this is implemented in Java is that you have what's called a try block, and you put your code inside of this try, and then you have a catch block, and that catch block really tells the compiler, okay, if an exception gets thrown, I can handle this exception, and then you can do something useful in order to be able to either repair the data or repair the damage that's been done, display an error message, or whatever you can do when that error occurs. So let's look at a simple example of using try and catch in order to create an exception handling logic inside of Java. I've got our Hello World project open here, and this was the project we created in the first course, and we had created this printer class and a whole series of classes related to printer here. And what we're going to do here is we're just going to do a very simple example of exception handling. We're actually going to throw an exception, and then we're going to catch that exception, and we're going to see how this could actually be useful. So if you remember, we had a print method here, this print method inside of our printer class, and it could print a number of copies that we had implemented here. Now, one thing that we might want to guard against is if someone were to pass in a negative number for copies, because we can't really print a negative number of copies. It doesn't make much sense. If we had that happen, this code really isn't going to have much of a problem, but because we know that this is really an impossible condition, we might want to throw an exception here because this indicates that something is wrong with the code that's calling this. So because you should never try to print a negative number of copies, throwing an exception here is something that could be argued to be a good thing to do because it would prevent possible future errors. Even though it might not cause an error now, it's sometimes good to guard against that. And this is kind of a debated topic, and I've kind of fallen on both sides of this in the past, but I can definitely see the argument either way. In this example, we're going to go ahead and do this and guard against this case. You can't obviously guard against every case and check every parameter and every method that you create in Java because you would have just so much error checking and error handling code. But in this case, it really does make sense because copies being negative is something that's invalid, and it's certainly something that seems like someone could try to do. So the first thing we're going to do here is we're actually going to throw an exception. We're going to check to see if copies is less than 0. So if it's a negative number, 0 would be allowed. Then we're going to throw, and this is the keyword that we use in order to create an exception. Now, a lot of times when you're writing Java code, you're not going to necessarily be using throw. Instead, you're going to be catching exceptions that other classes or maybe file IO or built-in libraries can throw. But if you need to throw an exception in your code, this is what we use in order to do that. And so in this case, we're going to throw an exception because this really is a error. It's really an error condition if someone's trying to print less than 0 copies or a negative number of copies. So I'm going to go ahead and throw, and then we're going to create a new type of exception here. We're going to create a new illegal argument exception. So a lot of times if you're throwing an exception, you'd actually be creating a new exception class and inheriting from one of the existing exceptions. In this case, we're going to keep this pretty simple, so we're not going to do that. But just so you know, in this case also, when you have an illegal argument, it's perfectly fine to use illegal argument exception because it clearly indicates what the problem is. We can also pass into the exception when we create the exception usually a string that's a message, and so we could say that can't print less than 0 copies. And so now that information is going to be propagated up, and this is useful for debugging to know what had happened that had caused the exception. So let's go into our Hello World main program here, and I've kind of cleared this out, and we're going to go ahead and try to print an illegal number of copies and see what happens here. First, we'll do this without the try catch. So I'm going to do printer.print, and I'm going to put -1 in here, and then we'll run this. Now you can see it just said exception in thread main, and this really would have aborted our program. It would have caused our program to crash if we had more going on here. You can see it's thrown this illegal argument exception. We can see the message on the exception, and we can see the stack trace of where this blew up. But this is not necessarily something that we want to crash the program, especially if we can handle this situation. So in this case, this is where the try catch comes in. We can basically wrap this call inside of a try block here, just by using this try keyword and then creating a block below it. And then we need to use catch here to catch the specific type of exception that we're wanting to do something with. So let's go ahead and create an illegal argument exception called exception. And you can see that by using the syntax, we're going to be able to catch this kind of exception explicitly. And then once we have this exception, we could just print out the message here, and we can get it from the exception. So we can call exception.getMessage. And what that will do is that will get the message that we had stored when we threw the exception. So let's go ahead and run this and see what happens now. Now you can see that it's just printing out this message, can't print less than 0 copies. It's not actually crashing the program because we've caught the exception. And so this is pretty useful when you want to not necessarily abort the program, but you are expecting that something bad could happen. You're checking for this error condition. Now this can also be used to make our exception basically bubble up above method calls. And what I mean by that is if we were to go into our printer here, you can see that we're just calling print and we're throwing the exception inside here. So it's not really much of a surprise that we could catch the exception here. But if we refactor this code and put this in a method, you can see that it's going to bubble up all the way up to our Hello World Java. So let's take a look here. Let's refactor. Let's do extract method here. And let's create a new method. And we'll call this method check copies. And let's make sure we name this properly for Java, which is a lowercase for methods. That's just the convention for Java methods. And so now we're calling this method called check copies, passing in copies. And you can see this check copies throws this exception. Now what you're going to see happen here is that we are actually going to throw the exception here. It's going to see that there's not a try catch here. We could put a try catch here and catch the exception, but that wouldn't really be a good idea because this isn't the place that we're going to really be able to do something useful. Instead, we're going to have that exception go all the way up, and it'll just keep on going up the call stack until it reaches the top, in which case it'll end our program, or it reaches some catch block that's going to catch the exception. So let's see what happens when we run this. You can see we get the same result. So now what's happening is our exception is bubbling up from check copies, throws the exception here, comes all the way up, exception keeps going up, and then it gets caught right here. So that's the basics of using try and catch to catch an exception.